Hi guys, continuing MATLAB lectures, lecture number 3, part 2. In this part, as I told you, we'll solve some exercises. Let us solve exercise number 1 here. It says that write a MATLAB program to ask user to input a number, which is n, then check this value as the following. If n it's an integer, print message showing the number it is an integer number. If not, an integer, we have to keep ask user to enter a number and check the number until we get an integer using a loop. We can use as a hint, you can use modulus of n to 1 to check integers. I will show you in the solution, but just here let us look at the flow chart. Start of the program. Ask user to enter the value of n, then check the value of n. It is the modulus of n. It is equal to modulus of n to 1. Is it equal to 0 or not? If yes, it is an integer. Print message and end the program. If no, we have to keep asking user to enter an integer until we get the integer. That means this flow chart, it's supposed that as a student you have ability to change the flow chart. It's given just a simple flow chart for you, and it should be a student task to change this flow chart. Surely here we have to place a loop. So how we can write the program? As I told you, CLC clear at the beginning, close all in different lines. So we have like this. Then we will ask user to input an integer, which is n. So we can write n equal, we'll use the input function. So input, we have to ask user, please enter a number, any number, say it should be n. Then go to next line. Outside, I don't want to see the result in the command window, just keep it in the workspace. Then we have to check the user the number entered by user, if it is an integer or not. So we have to use if statement. If we will use the modulus built-in function, modulus this number to 1. If the modulus of this number to 1 equal to 0, that means it is an integer. In this case, we will print message. So we can say that if print f, you can use display, it's up to you, but I prefer to use print f function. The number, which is %d or %f, anything, never mind. This number, okay, it is an integer number. Which number? Go to next line first, outside the quotation, comma, which number? It is n, like that. Else what? Now here we have to update the flow chart. We need a loop. Else we can write while. Say that 1. Okay, we have to keep ask user. We can repeat the same command. We can repeat, please enter n again, Ctrl C, Ctrl V. Please enter n again, enter n again. Make the message more clear again. Okay, and then we have to read it and save it inside n, and semicolon. We don't want to see the result in the command window. And then we use if again, Ctrl C, okay, Ctrl V. If modulus of n to 1 equal to 0, okay, in this case print the message like this, and then exit from the loop. We can say that break if this is true, because we got integer number. That's it. No need for else, because if this is true, this will be executed and then it will exit from the loop. If this is not true, it will go back to while loop. But here we have to write the end of the if statement first, and end of the while loop second, and finally end of the if statement, the outside one. So see, read the number at the beginning. This is for this one. Check if the modulus of n to 1 equal to 0 for this one. If yes, print the result for this one, and then exit. So if this is true, it will not go to the else. It will go outside the if statement and go to here. Say that we can print here display display the end. We can write here the end. Okay. So again, if this is true, it will print the message and go to the end. If this is false, it will go to inside else. Then it will start a new loop, infinite loop. It will keep asking. True, this is the end of the while loop. This is the end of the if statement, the outer one. Now inside this loop, we have this code. If the modulus of n to 1 equal 0, that means we got an integer. Print this message and then break. It will go outside this loop, the while loop, and it will go to outside, then outside the if statement, then to here, and that's it. Run the program. Please enter a number. This is 6. It is an integer. How we can control? We can print it as integer if you wish, like this. Run the program again. Please enter a number. This is 6. See, 6, it is an integer, the end. Okay. But in case we entered not an integer, I prefer to keep it. Float. To keep it float like this, better, because I want to show the fractions if it's not an integer. So 5 could be an integer. It's okay. But we have to control number of decimal places. Say that .1 better, and .1 better here. Run the program again. This is 5. See, 5, it's an integer. Then run the program again, and here we have to show you the process. 3.2, but the message is not clear. 3.2 still. 32. Now it's an integer, but the message is not clear. We have to write or make user-friendly program, because if you want to read the program here, please an integer, please, we can't understand what's happening inside the program, so it's better to go to here. Else we can write a message before this one. The number n, we can say that n is not an integer. Okay, please enter n again. Run the program to show you how the message now it's more clear. This is 3.2. See, n, but we have to change it from n to 3.2. So we have to here to print a number, which is 3.2 is not an integer. Please enter a number again and again. So let me Control C to abort the run, and let me go to here for the message. Instead of n here, write what? %f with just one decimal place, and from where I will get this value outside from the previous n or the current n. Run the program to show you the result. See, 3.2. Again, run the program. This is 3.2. %.1 is not an integer. Error using input. The second argument to input must be s. Where is it? Here. Percentage. Let me write it again. %.1f is not an integer. Please enter n again and print the value of n. There is no any error here. Let me try again. This is 3.2. Same error. Must be a string. Where is it? Okay, this message here, it's okay. Print running well, it's okay. F modulus Antoine integer. Aha, this is input. I'm sorry, this is input. For the input, we should not use this one. We can print it individually like this. So please enter n again. We can just do the following and remove the n here from the input. We can't use the input function in this way. We can write f print f like this. In between, we have to write Ctrl V. We can say that this number is not an integer, and then go to next line, then go to next line, which number it is n. Okay, so this number is not an integer, followed by please enter n again. So run the program, say please enter a number n, say 5, running well, no problem. Please enter a number n. By the way, let me abort the run. If it is integer and it's correct, it's better to remove the 0.1f. We can say integer because we know that it's integer. خلاص. Okay, so this number, prefer to show it as integer. And same thing here. This number is not an integer, please enter. If yes, same thing here. I prefer to make it d better. I will show you the result now. Now the program is perfect. Say this is 5. See, it's 5 as integer. Good. Now run the program again. 3.2. See, 3.2 is not an integer. Please enter in again. 3.2 again. 3.6 again. 3.9 again. Minus 3.9 again. Say 5 now. 5, it's an integer. It will stop. This is the number 1. Exercise number 1. Now exercise number 2. Write a MATLAB program to calculate the formula x factorial plus x factorial over 2 plus or minus x factorial over 3 plus x factorial over 4 minus and so on until reach x factorial divided by n. So here x and n should be entered by user. So let me start new script, CLC, clear, close all. Now let me ask user to enter x and n. So let me start by ask user to enter n. So n equal input, please enter n. Should be positive integer. Enter a positive integer n, and then go to next line. And then I don't want to see the number in the workspace. Next, as you read here, keep asking user to enter a valid value of n. That means the n, it should be a valid value. How? It should be a positive integer. So I will go back to this point later. Let me write here f, and this is the end of the f. If this number, which is n, less than 0, it says that here, remember that it should not be a 0 also. If the number it is less than 0 or equal to 0, that means not valid. Or this the modulus of this number, which is n, to 1 not equal to 0. In this case, it is not a valid. I want to repeat, asking user again. So I will ask user again. So Control C, Control V, but this time make the message more clear. Say that please re-enter a positive integer. Okay. If this is false, that means the number we got, which is n previously, it is valid and no need to do anything. We can continue like this. But this will check the n just one time. So I prefer to use, instead of f, while. This is the meaning, keep asking. Because if the current n it's not valid and next n it's valid, if we are using f, it will take it and continue. But if it's while, it keep checking the n again and again and again. So let me show you. This is f. I will show you. Run the program. Okay, please enter a positive integer. This is -1, not positive. Re-enter, this is -1. See, take it. It works for -1. It should not be that like that. It should ask again and again and again. So to solve this problem, use while to keep it continuously asking about integer. So this is -1, this is -1 again, this is -1 again, 1.5, 1.5, 1.5. Okay, now it is 5, which is positive integer, accept it. Okay, next step. Next step, it is again, keep asking user to enter a valid x value. X should be a positive integer, but could be 0. So we can repeat this code again. Control C, Control V, and I prefer to write a comment here. Read the value. Read the value of x. And same. Control C, Control V here. Read the value of the first one. It's n. Sorry. Read the value of n, not x. The second value, it's x, but we have to change the variable name to x here. And same thing, please enter a positive integer. Okay, while n less than or equal, no, remove the equal, because if it is equal to 0, accepted. Okay, again, this is x. If x, while x less than 0 or modulus of x to 1 not equal to 0, ask user to enter x again. And we can change the message here to x also, and here to x also. That's it. Let me run the program, show you. This is n. Let me put valid integer value. Please enter a positive x. I say that 2.5, a positive integer, not accepted. 3.2, not accepted. -2, not accepted. -2 again, not accepted. This is 2, accepted. Now x value and n value, they are good. They are valid, and we can use them. Next part, again, comment, Control C, Control V. Next part, use a loop to calculate the result. Now to calculate the result, we need a loop surely to go from I. See here, the first term, it is x factorial underscore 1. X factorial divided by 1, then 2, then 3, then 4, then 5. I will talk about negative sign later. Okay, imagine that all of these positive. So here, as you see, regarding x, the value it's fixed. Regarding the 1, 2, 3, 4, 5 until reach n, it's incremented by 1. So we can write a for loop. So for, we start from, say I, a counter name equal to 1 until reach n value, and this is the end of the for loop. End of the for loop. Inside this loop, we can say that we want the sum, the new sum equal the old sum plus the term which is x factorial divided by a counter. For the first term, it is x factorial divided by 1. For next one, x factorial divided by 2, and so on. So here we can write factorial. It's a built-in function, factorial of x divided by the I value, Remember that factorial of x, it's an integer, and I, it is an integer. So we don't want to lose the fractions. So the result will be integer. So I think it's better to write a float like this, multiplied by factorial. Okay, maybe it's better. And I don't want to see the result like this. That's it. Now this is if it is all these signs are positive, but for I equal 1, it is positive. For I equal 2 also, it is positive. 3 negative, 4 positive, and so on. So I prefer to do the following. If we say that this is let me start here before the for loop. I will start by sum equal, say it is x to the power 1 divided by factorial of 1. And we know, all of us, we know that factorial of 1, it is 1, but let me keep it like this, no problem. And again we can write x multiplied by 1 as a float like this. Okay, so I will start from the next I, which is 2. Now when it is 2, it is positive. When it is 3, negative. 4, positive. 5, negative. So for all odd numbers, odd integer increment values, it will be negative. For and also we can write, we can use if it is odd or even, but also I can write the following in the for loop. We can say that it is sum plus, say that power, say we can say that minus 1 as example to the power of I, and the result should be multiplied by this one. So we have minus 1 to the power of I multiplied by factorial of x divided by I. And remember that I start from 2 until reach n. And here as example, take n equal 3. Now minus 1 to the power of 3, it will be minus 1. Minus 1 to the power of 2, it will be 1. So for all odd integers, it will be positive, negative. For even, it will be positive, and this can work. Let me run the program, but let me change this comment. Find the sum of the series. The sum. Okay. Run the program to see if there is something wrong. Say that 1 and 1. Okay, running well. Now let me print the result. We can say that as see here. The output should be like the following: the summation. Let me copy it. Okay, let me copy. I'll show you how we can do it. Here we can write f print f. Okay, single quotation like this. We can Ctrl V, remove this quotation. We can say that summation or result. We can say that the result for n equal, and here we reserve a space for integer, and x equal, reserve a space for integer. We can say that equal to a number which is also an integer. Okay, or float. It's better to print as a float because summation, and remove this one. Then go to next line. Outside the quotation comma, the first number, it will be the value of n. Next one, it will be the value of x, and last one, it will be the value of sum or the result. Okay, let me check. X small, n small. Yes, like this. Now if x is 1 and n is just 1, it will be 1 over 1, 1. Okay, if n equal 2 and x equal 1, it will be 1 plus half. 1 plus half is 1.5. Let me run and check. So run the program. Let me enter 2. N is 2 and x is 1. The result is 0.5. Now let me just print just 2 decimal places. I will go back to here and write dot 2 like this. Now run the program again. We can say that for n equal 100, okay, and x equal to 1, see the result. Okay. Now the program should run continuously until using n or x to be minus 1. Now guys, as you see, that means I have to copy all of these, cut them like this, and then write a while loop, and this loop is infinite loop. This is the end of the while loop, and I will paste the code inside, and then align them correctly like this. This is while, this is inside the while, this is this here, this is here, this is here, this is inside the while, this end for the while, this is here, summation for, this is inside the for, this is end for the for, the print aligned with this, the end, and again like this. Outside the while loop we can write or display, if you wish, display the end of the file. We can say that the end. the end like this. Okay. Now we will read the value of n. We will read the value of x. Okay. Now the program should run continuously until using n or x to be -1. N or x to be -1. In this case, what we should do in this case, I think it's better to cut this one, okay, and paste it here. So read x and n at the beginning, then check the value of n and check the value of x, and reread x again and reread n again if they are not valid. So read the value of n and x. Okay. Control C, Control V. It's better to change this one to verify. Say that verify or check the value of n at the beginning, and for the next one, check the value of x. Check the value or verify. It's up to you. Okay. And why I'm doing that? Because I want to read the number n and x, and then before proceeding, if the value of n equal to -1 or the value of x equal to -1, if this is true, what I will do, I will break the loop. The break, it will break the loop, so the flow will go to the end of the loop, then display the end. Let me run the program. So please enter a positive integer. Say that this is again, I run the program again just to show another example. Say that this is -3, not valid, -2, not valid, 2.2, not valid, 2.3, not valid. This is 1 for n, it's valid. This is 5 for x, it's valid. The result will be n equal to 1 and x equal to 5. The result will be 5. Now this is -1 for n. This is 0 for x as example. The end, because one of them is negative. So I think the program now complete. It is a complete program, so we can check the question again. This part is done, this part is done, this part is done, this part is done, and the last thing, we have to draw the flow chart for this program. This is a task for students in the class. No need to record it now. So thank you for this part. We will solve the exercise number 3 in individual video. So thank you for watching this video, and see you in next video.